Let me ask you a simple question. What is the typical lifespan of Indians? You may not know the exact answer, but you will guess that it is around 70 and you will be right. Now let me ask you another question. What is the typical length of an adult male dolphin? Possibly you have no idea, but anyway, Google will give you an answer. Now comes the last question. What is the typical weight of a mammal? I am sure you do not know. I am sure you have never heard this question before. Will you turn to Google for an answer? No, this question is absurd. There are so many different types of mammals ranging from tiny rodents to enormous blue whales. What do you mean by typical here? All these questions mention a set of numbers. Lifespans of Indians in the first case, lengths of dolphins in the second, and body weights of mammals in the third. We need a typical value that represents that set. In the first two cases, such typical values make sense, but in the last, it doesn't. This is a common situation in real life. Sometimes we feel that a bunch of numbers are so close enough together that their essence may be captured by a single typical value. In some cases, no single value can represent the entire set meaningfully. It is hard to draw a line where a typical value starts becoming meaningless, but intuitively we can all feel this. If a bunch of numbers may reasonably be represented by a single typical value, we say that those numbers have a central tendency. Here the word tendency captures the somewhat intuitive and subjective flavor of the situation. If we have a variable whose values have central tendency, that is, a single typical value makes sense, then we are naturally interested in finding one. Any such way is called a measure of central tendency, and our first lesson is devoted to just this. We shall start with the most popular such measure. Commonly, people loosely refer to a typical value as the average, as in, what is the average cost of a two-bedroom flat? The term average also appears in a precise sense in school textbooks. The average of x1 to xn is the number x bar, which is the sum of all the xi's divided by n. We use the notation x bar to mean the average of xi's. Now, there is an important difference between these two usages of the term average. In the first sense, it conveys the somewhat intuitive notion of a typical value. In the second sense, it is a precise mathematical formula. To avoid any possible confusion between the two concepts, statistics uses two different terms to convey these two different meanings. When we want to mean typical value, we say a measure of central tendency. When we want to refer to the math formula, we say arithmetic mean or just simply the mean. Now, the fact that common man uses the same term average for both these purposes has its origin in the fact that mean is indeed the most popular measure of central tendency. But be very careful here. Mean is just a formula. It is always defined for any bunch of numbers, whether or not they show central tendency. Thus, if I ask what is the average body weight of mammals, then you can in principle just list all the body weights of all the mammals and find their mean. While that will definitely produce a number, that number will not be a meaningful answer to the original question. In fact, the question itself is absurd, because how can you measure central tendency when there is no central tendency?